Alrighty. Let us begin. Oh, oh, the announcement worked. Alrighty. So, this should be posted online. All right. This is I wrote practice for final exam or whatever. Usually here I'll just start, doing all the questions effectively. Okay. So if you do have any questions about anything, just feel free to stop me and we'll go into those parts a little more. All right. All right. A nurse measured the blood pressure of, and if you can't hear me or anything like that, just please let me know, for any reason. All right. Also, if you do know the answer, I would appreciate it if you answer the question. All right. Or if you think you know how to do it. All right. A nurse measured the blood pressure of each person who visited clinic following a relative frequency histogram for the stock blood pressure readings for those people aged between 25 and 40. Blood pressure readings were given to the nearest whole number. Approximately what percentage of the people aged 25 to 40 had a systolic blood pressure reading between 110 and 119 inclusive between these two? So it looks like 35%. All right. That one's not too bad. The manager of a bank. Oh, I've forgotten one thing that's very important. My calculator. The manager of a bank recorded the amount of time each person spent in line during business. The frequency distribution shows below. Find the mean waiting time. Okay. Yeah, I will need my calculator then, or I'd rather use my calculator. So I have to just do one var stats here, right? So, but the problem is this doesn't that's not like a number. So we need to find the midpoint of each of these things. That's like 1.5 plus 4, I guess. So 5.5, 9.5, 13.5, 17.5, was 21.5, 25, oops, 25.5. All right, and then we need the respective frequencies for those things. So 15, 14, 10, 8, 7, 2, 2. Okay. And now we just type it into one var stats, I guess. So one var stats, L1. I gotta shut off this stupid waiting room. I want to shut it off. Does it let me? Yeah, it shuts off. All right. Somehow this is stuck. Oh, there we go. L2. And that's it. And then the mean, it looks like, is 8.94. They say round to one decimal place, so 8.9, it looks like. Any question with that?
Nope.
Student earned the grades of the following courses or things. Okay. And grading system, whatever. Compute the grade point average. Okay, grade point average. So again, we're still just doing an average. So we just need to write our values and our frequencies, right? So they provide to us the values here, it looks like. So then that's 4, 3, 2, 1, 0, effectively for getting each of the grades A, B, C, D, whatever, right? And then the credits are how often those things are occurring. So what do I write here?
to 4626.
Here?
Yeah.
No.
No.
We did this example actually earlier, believe it or not, or a similar one. So it's how often the A is occurring, right? So this one's an A, that one's an A, so it's 6 and 6, it looks like. So that's 12. Then the B should be, I guess, 2. And then the C's are 4. And then these are 0, I guess. So we have to calculate the average. Could just type this into L1 and L2. And that'll work. Either that or this is just 48, 6, and 8. So that's 14 plus 48 is what, 62 divided by, this is 6 is 18. 31 over 9 is what, 27 and 4/9. Let's see if I was right. I don't know if I'm right this time. Okay, so again, just type this crap in, I guess. Clear this out. Clear this out. 4, 3, 2. 12. Oops, that doesn't look like 12. 12, 2, 4. And then do one of our stats again. Oh god, I wasn't. How did I get 27? That makes absolutely no sense. Six, 18. So I guess, well, whatever. The answer is this thing. But what did I do wrong? 3.44 here. So then this, the formula should be the sum of the values times the frequencies all over the sum of the frequencies. So that's why I was multiplying these two. Did I type the same thing in the calculator? Must have multiplied wrong. 4 times 12 is what? 48. 3 times 2 is 6. 2 times 4 is 8, right? 48 plus 6 plus 8 is 6 plus 8 is 14. 14 plus 48 is 62. So then this is 62 over 18. Oh yeah, I'm just dumb. Okay, so this is 31 over 9. I said that correctly before also. That was right. This, I don't know what I was doing before. Oh, I know what I was doing. 9? How many times is 9 going to 31? 3 times? 3 times 9 is 27. For some reason, I started writing 27. So this is 3 and 4/7. This is 3.444444, excuse me. So then we get 3.44, same answer. All right. But of course, you don't really have to do it with the formula, just do it on the calculator. Coefficient of variation. Coefficient of variation is the standard deviation divided by the mean. So then we just have to do it for both of these, it looks like. So we do that. So we have to type all this crap in yet again. I think I'll do it for one of them. And then you guys can do the other one if you want later. Remember, don't keep messing up typing like I'm doing, because that'll be a problem. Also, don't forget to bring your calculator to the final exam, all right? so this thing. Okay, so then really all we're gonna do here is I guess just go to one of our stats again. And now we get that the standard deviation is this number. I'm just gonna write that down, whatever this number is. 5810. 85. And then divide that by the mean, so it's 507.3. So this is for this group. So let me just do that on our calculator, whatever this nonsense was. 19.28581085 divided by 507.3, it looks like. And we get this, that this is approximately equal to, this round to 1 decimal place. Usually you write this as a percentage. I'm not 100% sure what it means with 1 decimal place, so I assume it means 1 decimal place when you're writing as percentage. So this is going to be 3.8%. The standard deviation, or yeah, the standard deviation is about 3.8% of the average. Okay. For the first group. So in other words, all you have to do here is do 1 var stats and then take the mean divided by the standard deviation. Question with this? Any question here?
Nope.
You guys there?
Nope.
If the standard deviation of a set of data is 0, what can you conclude about the values? What would you say here? This means,
There is no variation.
right? That's true. But what would it mean then? What can you say about the values?
They're all
Same.
the same.
They're all the same. Perfect. Good. They are all the same. So why is that? So the standard deviation is 0, then that means the variance is 0, right? The variance is the sum of the data value minus the mean squared all over n minus 1. If this is 0, like this is just some number, like 12 or something or whatever. This is a bunch of squared stuff though. So like this is like saying like you take some first number, you're subtracting the mean, but then you're squaring it. So it becomes positive. This one minus the mean, you square it. Unless these are all like 0. Unless these are all 0. This one, this one, this one, this one, all of these things, you're not going to be able to get 0. So in other words, if it's 0, then that means xi minus x bar must be 0. So xi must equal to x bar in that case. In other words, every single data value is equal to the average, or they're all the same. Okay.
Mhm.
Find the percentile for the data value 6. All right. So this is kind of stupid. We have to order them and stuff like that. I hate these questions, but first you got to count how many there are. 1, what is this? 2. Somebody count with me so I don't mess this up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, so that was actually good. There's 20 numbers. Data value 6. All right, so what does percentile mean again? Percentile is the number less than divided by the sample size. So in this case, sample size is 20. The number of values less than 6, 1, 2, 3, 4, 5, 6, 7, 7. So I guess this is 14%. Oops, that's not 14%, 35%. Any question there?
Nope.
Well, I counted correctly. The weights of these things, find P16. A. Let's see if I remember. All right, so then, the percentage is equal to like the number divided by the total. So if we want the 16th percentage, then the number of values less than the one we're looking for over the sample size should be this. So the number sample size is 30. So this means 16% of 30 is what we need, which is 4.8. You could really just jump to this. Then 4.8. So we need 4.8 values less than whatever. The 4.8 values should be less than whatever P16 is. So 4.8. So this is the first value, the second value, third value, fourth value. This is the fifth value. So then this is the first thing that's going to be larger than 4.8. So then we select this one. So don't forget, you could pick the one in between also. Okay. But this would be like 4.5. That's not big enough yet. So in this case, we select X5. X5 is 6.1. So we get 6.1. Any question with this one?
Nope.
Study of consumer smoking habits includes 185 in the 18 to age 22, 122 in this bracket, and 85 in this bracket. If a person is randomly selected from the sample, find the probability of someone who is age 18 to 22 or does not smoke. Find the probability that they're between 18 to 22 or they don't smoke. I'm just going to write S for smoke. So then that thing means not S. So then this is, we can just start counting, or I can do it with the formula. I would just start counting, to be honest. So 18 to 22, they tell you there's 185 people, okay? First of all, we need to know how many total people there are, I guess. I said always do the denominator first. So in this case, there's 185 plus 122 plus 85 total people, right? Then it says that we want this stuff. So those are the favorable things. So we need to count that, put that on the numerator. So then that's going to be 18 to 22 is 185. Now we just have to count the people who don't smoke, who we haven't already counted. So then out of these, 32 smoke in the 122. So then we should do 122 minus the 32. And then 27 smoke in the 85. So then we do 85 minus the 27. And then whatever this is, that's the answer. Does that make sense?
Yes.
All right. Again, if anybody has any questions, we can write this out more. What is this? Determine the decision criteria for rejecting the null hypothesis in the test. Describe the values. The test statistic. Suppose you wish to test a claim that the mean difference in the values for a population of paired data is different from 0. Okay, so then that means this has to be 0. This is not 0 because that's what we're trying to show. Then, given a sample of n equal to 23, simply for this level of alpha is this, what criterion would be used for rejecting the null hypothesis? All right. So then, whether it's T or Z, it looks more or less like that, right? Then alpha is 0.05. In this case, this is a two-sided test. That means that has to be put onto both sides. So then this side and this side summed together would give you 5%. So that means one of the sides is 0.025 and the other one is 0.025. Yikes. And then we need to figure out what these two positions are so we can discuss if there's going to be a z-score higher or lower than these things. So this is z of 0.025, and this is Z of 0.975. Z of 0.025 is inv norm. Oh wait, do we do Z here?
Mm.
No, we can't do Z. That's actually why they're telling us this. Because we don't have enough to start saying that it's, first of all, they would actually have to start telling you that the data is normally distributed. They didn't even say that. Okay, so that's kind of bad. But we really need to do T in this case, because we said that when we were doing the paired data tests, those all are gonna more or less be T tests, because we're never gonna know what sigma is in those cases. So in this case, we need to figure out what each one of these two things are. This would then imply that the degrees of freedom is what, 22, right? So then we just do that. So this is now T of 0.05 22 is inverse T, and then we have to again tell it the area to the left. So we just go to inverse T on our calculator. Area to the left in this case would be 97.5%. Degrees of freedom is 22. I guess this was the exact same question we did earlier in the class. So then this is, so we just do that again. That's funny. The last time I typed it, it was the same thing. I must have just done this a couple days ago. So this means 2.0739. Okay, that's the approximate T value for that. And then when we do the other side, now it's 0.025 is to the left. Now if it's 2.07 standard deviations this way, it's going to be negative 2.7007, whatever standard deviations the other way. I'll just do it again anyway, but we don't really have to. Okay. Any question? Table below smoking habits, asthma sufferers. One of the 1123 is random selected. Find the probability of getting a regular or heavy smoker. Well, this one's easy actually. So regular or heavy smoker. If this is on the test, you should be happy, to be honest.
Mm.
So regular or heavy, all we do is they already gave us the totals here, right? So it's like we could just think of it sort of like this. Oops. Like this. So it's like this many favorable out of the total, but they already told us the total. So it's 162 plus 69 all over 1123. And that's it. Which I guess you could simplify that a little bit, but whatever. You could also you just do it on your calculator, but does anybody have any question with this?
Nope.
Do you want the answer in a fraction form or a percentage?
It depends on what the question's asking, but honestly, if it's not asking you, the best answer would be to write it as a fraction. Okay.
Okay.
The problem is this could possibly be simplified. Don't know, honestly. We'd have to start checking if this is going to be able to be simplified. 7 going to this, or 2, 6, no. So then I'd have to start seeing if this is going to be able to be simplified, but I don't think it's going to be able to be. But usually what it'll ask you on the test is it'll ask you for some sort of decimal. So you just approximate to whatever the decimal place it's asking. Otherwise, if the answer choices are in fractions, then obviously you have to pick it that way, but that's about it. Is event B dependent or independent of event A? A bird lands on your head, the bird lays an egg. I guess it's independent. I mean, I don't, unless you start I hate these questions because there's always like 27 answers if you really think about it. But like, if the bird could not lay an egg on your head, then they're dependent. If the bird can lay an egg on your head, then they're independent. Does that make sense? Because if the bird can land on your head and then it actually can't lay an egg, then every single time it lands on your head, it can't lay an egg. So there is an association then. So it's not independent at that point. But if you assume that the bird can lay an egg on your head, then it's independent. So I wrote independent. Find the probability of correct. The one on the test is not like that. So it's, find the probability of correctly answering the first 5 questions on multiple choice tests if random guesses are made on each question. It's 3 possible answers. Correctly answering. So this would be like 1/3, 1/3, 1/3, 1/3, 1/3. So then we get 1/3 to the 5, which is what, 243 or something. Again, if you have a question, please let me know. You were dealt 2 cards successfully without replacement from a 52 card deck. Find the probability that both are black. All right. There'd be a half chance the first one would be black. The second one, the chances it would be black. Well, there's what, 52, so then out of the 51 cards remaining, there would be 25 black ones. So this means you would get 25 out of, what is this, 102. Any question?
Nope.
Unprepared student makes random guesses for 10 true false quiz. Find the probability at least one is correct. Probability at least one correct is the same thing as saying the probability of 9 or less wrong. So then you could say then this is just a binom CDF. 9 or less wrong, so N is 10. 9 or less. Oh wait, no, it's NPX, sorry. So P is 50%. And then X is 9 successes or less. You could do that, or you could think of this as 1 minus the probability of the complement of this. So then if you start saying that you have to get at least 1 correct, the complement of that is none correct. This 0 correct means you get the first one wrong, it's 1/2. Second one wrong, 1/2. Third one wrong, 1/2. Blah, 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 blah. It's all 1/2. So this would just be 1 minus 1/2 to the power of 10. That's 1 minus 1/1024 or 1023 over 1024. Or we could do it this way using the calculator. When we originally learned this, we didn't actually know how to use the calculator yet then. But now we do. So we get this. And this should be the same number. Okay. Question here?
Nope.
Pierre has 3 coins, one of which is biased, so it turns up 65% of the time. If he randomly selects one of the coins, tosses it 3 times, obtains 3 tails, what is the probability that is the biased coin? What? Pierre has 3 coins. Okay. One of which is biased. So there's a biased coin and then 2 non-biased coins. All right. If he randomly selects and tosses the coin 3 times, and obtains 3 tails. What is the probability it was the bias coin? So what is the probability that given got 3, what's the probability it's the bias coin? Given that he got 3 tails, I guess. Alright, so then this is the probability that it's biased and 3 tails. Divided by the probability it's 3 tails. Okay. Looks like we're gonna do some sort of like Bayes thing. So biased and 3 tails, so the chances it's biased is 65%. Alright. So, oh, but first we have to start saying what's the chances it's actually gonna be biased. Then to get tails, there's 2 ways we could end up getting the 3 tails. So one way is if it's biased. So it either could be biased and 3 tails. Or it could be not biased. And 3 tails. Those are the 2 ways we can end up getting that, right? So then, in this case, these 2 are disjoint from each other. We're not gonna be able to get biased and unbiased at the same time since we're only selecting 1 coin. So then the chances that we do this is just this one effectively plus this one. So then this is the chances it's biased times the probability that it's 3 tails, given it's biased. Plus the chances that it's not biased times the probability that you get 3 tails given it's not biased. So then we have to do that stuff down here. So all this goes down here. So then we just start writing this out. So this is 65% of that, oops. The chances it's biased is 1/3. Then the chances you get 3 tails, given it's biased, is 0.65, 0.65, 0.65. So then we have to write that over here also. So that's 1/3 times 0.65 cubed. Somehow this all just got erased. Then we have to do this part. So now there's a 2/3 chance it's not biased. Now the chances of getting heads with a non-biased coin would be, I guess, 1/2 cubed. 1/2 times 1/2 times 1/2. I guess we can multiply by 3 here, so we don't have to do all these stupid 3s. So 0.65 cubed over 0.65 cubed plus 2 times 1/2 cubed. 2 times 1/2 cubed is just 1/2 squared. So that's 1/4. So when we do this on the calculator, whatever this is. 0.65, this one's hard though. This one's a lot harder than the one that's actually on your test, as far as I recall. I guess I was just trying to make sure we did something that's kind of does everything. This one's fairly hard though. 0.5235, 0.5235. Okay. Any question?
No.
That one's harder though. That was probably the hardest one to test.
There's-
How many?
Oh, sorry. There's no like easier ways to do those questions like those That's just like, they're all gonna be that long.
If it's, no. Like usually they don't make you calculate something here. And here. And here. That's why this one's harder.
Oh, okay.
But usually it's just. Like, identify these values. And then whatever. You know, that somehow they usually tell you what this is in the question.
Oh,
Does that make
okay.
sense?
Yeah.
But otherwise, if it's a base theorem question, there's no way it could be shorter than that, though. Does that make sense? This is still
Yeah.
fair. This is still pretty short for one of these questions. Does that make sense?
Yeah.
Unfortunately, it can get much worse. How many 5-digit numbers can be formed using the following digits if repetition of digits is not allowed? Okay, so then there's 7 choices, 6 choices, 5 choices, 4 choices, 3 choices, I guess. So let me just multiply this garbage out. So this is 20, this is 42, that's 2 is 84, 0. Then multiply that by 3, so then we get 24, 12 is 520, I think. I feel like I just made a mistake.
No,
No?
I don't think so.
But the point is I don't even care if I'm taking a test, I'm typing in the calculator anyway. And just making sure it's right. How many ways can 6 people be, any question with this one before we move on?
Mm-mm.
How many ways can 6 people, you could have also done this by doing, what is it?
NPR.
Yes, 7p5, right? Because there's 7 things and you're trying to say how many permutations of 5. So that's 7, 5, yeah. Okay. How many ways can 6 people be chosen and arranged in a straight line if there are 8 people to choose from? So this is almost the same question, honestly. 8p6. So this is the same thing, but just multiplied by 8. Because this would be 8 times 7 times 6 times 5 times 4 times 3, because we want to pick 6 people, right? So it should be just whatever this last thing is times 8. So it's 0, 6, 1 is 8 is 41. Here the 4, 2 times 8, 16, 17, I think. Whoops, not even close. Oh yeah, I said add 4. Stupid. Okay, question with this?
Nope.
So this one's gonna be probably an example for combinations now, because now they're started talking about subcommittees now. So this is gonna be 13C4. That's just 13 times 12 times 11 times 10 over 4, 3, 2, 1. So then we get 55 times, what is this, 65 times 11 is 650 plus 65 is 5, 11, 1 is 7 thing, yes. 13 times 11 times 5. Okay. Math. This one, we could have done it this way also, just type it in the stupid calculator. Much simpler. 13. 4. Yay. So all you have to do is be able to recognize here that these ones, the order matters. And then this one, the order does not matter. So in this one, we do combination. These two, we do permutation. Any question about any of these?
Nope.
You good there, Justo? You awake?
Who, me?
Yeah, I'm just playing around. So in a certain town, 60% of adults have a college degree. The accompanying table describes the probability distribution for the number of adults who have a college degree. Find the standard deviation. Oh, so actually, I gotta say, like, I don't like these questions, but if I was taking the test, like, at least I know I can get this right because I'm just gonna type it in. Because it says standard deviation, so like I'm not doing this out. So we gonna one var stats yet again. I don't know how many questions we've done one var stats to get the answer for, but it's been a lot so far. Has everybody seen that so far?
Yep.
Like, so when we do this, now the only thing is we just have to make sure that we read the right one off, whether it's standard deviation or sigma. But it's not even giving me sample standard deviation in this case, because it already knows it's a probability distribution because it already added up to 1. So we literally just copy the number now. It says rounds to the nearest hundredth here. So that's 0.98, I guess. If I typed everything right. Question?
No.
Soon there's a 5% chance that a sports series will last 4 games, a 45% chance that it'll last 5 games, 45% chance that it'll last 6 games, 50% chance, 5% chance to last 7 games. It is unusual for a team to win in 4 games. So if they're gonna win in 4 games, it says there's a 5% chance. Unusual, at the beginning of the book, they say it's 5% or less. Then later on, we start saying alpha, we consider it to be 5%, and then we want the p-value to actually be less than that. So it depends on which criteria you're honestly using. Does that make sense?
Yes.
They're gonna use this one in this case, though. Any question with what I mean by this stuff here? Right, remember when we do p-value is less than this, that really means it's more or less like rare enough.
Mhm.
28-year-old man pays $214 for a 1-year life insurance policy. It covers 100,000. Probability that he will live through the year is 9,993. What is the expected value for the insurance policy? Oh, so the amount of money that I'm going to get afterwards versus the probability of those particular events. If I live, I'm going to lose $214, I guess. That's going to happen with a 99.93 probability. If I don't live, then somebody gets $100,000, but I paid my 214. So we should, and then this must be the complement. So that's, I just subtracted it from 1. So then we just do that. And we type that in our calculator and do one var stats. Because again, now I have the values and the frequencies. Does anybody have any question with this one? Do you understand what I'm doing here?
Yes.
Okay. All right. Stat, calc, one var stats, L1, L2, whatever. I guess it's worth about it. You're expected to get, the expected value of the amount of money that you're going to have at the end of the policy is negative $144. Which makes sense. Like, they're not going to give you a policy for nothing. Does that make sense?
Mm-hmm.
Determine if this is a binomial distribution, if not statewide. Choosing 3 marbles from a box of 40 with these colors, one at a time without replacement, keeping track of the number of red marbles chosen. Not binomial. The reason why is trials are not independent. Why are they not independent? Because like if I'm selecting from a fixed bag of 40 marbles. Does that make sense?
Mm-hmm.
Each time the chance of selecting a red one is actually changing, not remaining the same. So trials are not independent, or you could have said P is not constant. The probability of success, or let's be more specific, the probability of getting red is not constant. Does that make sense?
Mm-hmm.
A slot machine in a hotel is configured so there's a 1 in a 1400 probability of winning any jackpots, and if the guest plays the slot machine 8 times for the probability of winning exactly 2 jackpots. So this is just binomial. Binom PDF. N is 8. They said they win with this rate, so that's 1 out of 1400. We want to win 2. So does that make sense?
Yes.
And then you just do this on your calculator. I mean, I guess we could even honestly just do this by hand. This is not even that bad. All right, but I would just do this on my calculator, okay? I'm gonna write it out by hand anyway, just because I'm an idiot. So this is 8 times 7 over 2 times 1. So that's 28 times the chance of success to the power of the number of successes, which we said 2, and then the chance of failure to the number of failures. So that would be 6. If you work either of these two out, you get the same. Okay?
Mhm.
A company manufactures batteries in batches of 10 and there's a 3% rate of defects. Find the variance of the number of defects per batch. Okay. Standard deviation. This is again binomial. Standard deviation is square root of NPQ. So that means variance is just NPQ. So then N is 10. P is, they said the variance for the number of, it doesn't even matter. Anyway, so this is 3%. Because that's the rate of success in this case. Defect is getting a success. And then failure is 97%. So we just multiply this out and we get the answer. Any question with that? Told you have to know that formula. If Z,
For the last question, it gave me a really small number. How would you want us to write it? Like it gave me 1.422459902.
it would
Exponent
depend,
-5.
it'll have to tell you on the test. In this case, it says, which one was that? It says this. Do you see this?
Yeah, I can see it.
Right. So it'll indicate it on the exam. Okay.
Okay.
If Z is a standard normal variable, find the probability of this thing. So all we do is normal CDF. I forgot to draw the picture. So this is less than 0.97. So that's like over here somewhere. So less than that. If it says Z is standard normal. So that means the mean is 0, standard deviation is 1. So then this is just what? -1 E99, comma 0.97, and that's it. Any question with that one?
Nope.
Find the indicated value. I mean, we really already did one that's harder than this one. Wait a second. Did I finish that one? Now I'm like getting neurotic. We had done it in class, so that was the problem. I did it again. Oh, the T things. Okay, so I never actually stated here on this question. They said what criterion would be used for rejecting the null hypothesis? It should be that if I forgot to write this part, if T is like over here, so if T is greater than, approximately 2.0739, or T is over there, which is less than negative 2.0739. Forgot to answer the question. Okay,
Mhm.
question with that?
Nope.
Does that make sense?
Nope.
It's kind of the easy part, but I just decided not to do it, I guess. All right, now just remember when they put the number over here, that's the only time in the class it means to the right. And it's not Beyonce, okay? All right, so this is 0.01. So now we need to find that particular value right there, Z of 0.01. Can everybody hear me?
Yep.
All right. So that means this side is 99%. Do you remember how to find this guy? How do you find the Z-score of this position?
Is it inverse norm?
Mm-hmm. Inverse norm. And then the calculator is going to ask you for the area. So all at once is the area to the left. So we just do that. Okay.
Mhm.
All right. Assume that women's heights are normally distributed. All right. So women's heights are normally distributed with a mean of 63.6 and a standard deviation of it says 2.5. 90 women are selected. Find the probability of the mean height. Is between 62.9 and 64.0. All right, well, the mean heights though would be also normal because they said 90 if they're randomly selected, but they said randomly selected also. So then the mean heights, the average of the average is still going to be the same, but the standard deviation is going to change to 2.5 over square root of 90 by the central limit theorem. So then this, we still do normal CDF, but we have to deal with this now. So then this is 62.9, 64.0. Mean is 63.6. Standard deviation is 2.5 over root 90. Either that, or you could do it if you want to do it by Z-scores. Then it'd be 62.9 minus 63.6 over 2.5 over square root of 90. And 64 minus 62.6 all over 2.5 over square root of 90. Does that make sense?
Yes.
So like 64 is somewhere over here. 62.9 is like over there somewhere. And they want us to find that probability. Now, this is the adjusted standard deviation for the standard error of the mean. Does that make sense?
Yes.
Women's heights are normally distributed with mean of 63.6, standard deviation 2.5. Find the value of Q3. Q3 means it has 75% to its left. So mean here is 63.6, standard deviation is 2.5. Standard they want that position, so it's almost the same question as the one a couple before. This is just now, you have to do it with a non-standard normal distribution. So 0.75 mean is 63.6, standard deviation is 2.5. You could do it that way, or you could do it by saying the mean plus in norm 0.75 times 2.5, because you could do like mu plus z times sigma. Either of these should give you the same thing. Find the area of the shaded region. This one's easy. Normal CDF -1 E99, 110 minus 100 over 15, or normal CDF -1 E99, 110, 115. Question with either of these two.
Nope.
Alright, finds the alpha over two, the corresponds confidence level of this thing. Okay. So this is that then, I guess. Z alpha over two is the one over there. So that means I need to know what alpha is. So this is, this one plus this one would have to be what, 0.1052? So that means this one is 0.0526, I guess.
Yes.
So then this position here would have to be either the sum of these two or just one minus this, either way. But inv norm, because they said z, inv norm of 0.052, so let's just add it, 0.8948, 0.0526. So that's 4, 1 is 3 is 7, 14 is 9, I think. Is that right?
Mm,
Nobody wants to check from me.
yes.
Is correct?
Yes.
1 minus 0.8948 divided by 2. This plus 0.8948. Yay. Alright, this, and that's it, gives you the answer. No, this garbage, this is easy. Alright, so express the confidence interval in the form of this thing. This is another one you should be happy if it's on the test, or when it's on the test, excuse me, I should say. So to get p hat is just the average of these two, so that's 0.432 plus 0.52 divided by 2. And then E is the distance between these two things, but divided by 2. So then that's 0.52 minus 0.432 divided by 2. Does it make sense?
Yes.
Okay. User given a confidence interval, population mean, assume the population number is 30, randomly selected students took calculus final sample mean was 95. Standard deviation was 6.6. I mean, we could just type it in. We don't need to write it out, I guess. So this is mean. So that means we gotta select between Z and T. It says 30 randomly selected students. Like, that's not everybody. So it's T, because we don't know sigma. X bar is 95, standard deviation is 6.6, N is 30. Confidence interval, this should be 99%, and that's it. So we get this is the answer, 91, 6, 7, 9, 98, 3, 2, 1.
Mhm.
Question with this?
Nope.
Not that it really matters, but on the final, will there be any multiple choice questions?
Yeah, there will. Some
Okay.
of them. All right, but don't forget, any of the ones that aren't multiple choice, I'm grading them by hand. So like if you answered, like you were asking previously, if you answered 3/20, or you answered 15%, I mean, or you answered this, or you answered this, I'm gonna be marking it correct. Does that make sense?
Mhm.
Got it.
I'm looking to see if you did it right, not if you missed a word in the question in terms of, like, I'd rather them not, okay, when they put on the test round to 2 decimal places, I see more people get it wrong because they don't read that, or they did it wrong, or whatever, right? So I'd rather you actually be able to leave it like this, so you don't have to do the additional steps. Does that make sense?
Mhm.
So would it be more helpful for us to like show the work on the test?
The work isn't gonna matter because I'm only gonna grade the final answer. But if you, because the problem is that if you've made a mistake on it, I can't provide you partial credit since there's usually only one step. Does that make sense?
Got it, got it.
All right. Um, identify the distribution that follows the following things in confidence interval of sigma. So like we didn't really talk about this. I guess this is no longer in the class anymore or whatever, but it's chi-squared. Effectively, anytime it's skewed, that's the only skewed distribution we used to talk about. But don't worry about that one. It's not gonna be any test anyway. Fill in the blank. The critical t-value t alpha over 2 that corresponds to a blank confidence level is this. What? Oh, okay. This question's like sort of really bad, actually. You can't do it. So like if that's 2.33 and then that over there is negative 2.33, then we should be able to figure out the confidence level here. The only problem is that it doesn't tell me what n is. So since I don't know what n is, I don't know what the degrees of freedom are, which means we really can't figure this question out. It looks like there's a mistake. But the thing is that if I want to be as conservative as possible, so I can pick the minimum possible confidence level I can tell someone that this is going to give them, then I'm going to make the degrees of freedom as small as possible. So that means the degrees of freedom would be 1. Because n would be 2, I guess. So then if I do that, then we have to figure out what TCDF is going to be from negative 2.33 to 2.33, and then the degrees of freedom is 1. So let's see what that gives us. This question is flawed, though. In other words, it would not be worded like this on your exam. Negative 2.33, 2.33 degrees of freedom we said was 1. So does it make sense? Like this would be the least confident. You'd be the least confident when you have 2 data points, right?
Mhm.
So look at this. So the best you could say is that the confidence level is greater than 74.19%. Let's just go with 74%, 74%. So they forgot to mention N. If you want, we can start guessing what their N would have had to be. So let's say if N was, I don't know, 11 or 12, then it's already 96%. So there's none of that. If N was 9, oops. See, we can make it like whatever we want. That's the problem here. If N was 9, whoops, maybe I should type correctly. Then we get 90, almost 95%. 96, whatever. But you see what I'm saying here? We need to be told what N is. Use the given data to find the minimum sample size to estimate the population proportion. Okay. So what's the formula? So it's like P hat minus P all over, or excuse me. The margin of error is equal to the number of standard deviations times the standard deviation. Number of standard deviations would be some Z alpha over 2. Standard deviation for a proportion is square root, if we're estimating confidence interval, is P hat Q hat over N. We have to solve for N here. So then we get root N equals Z alpha over 2, square root of P hat Q hat over E. Squaring both sides, you get N is equal to Z alpha over 2 squared times P hat Q hat over E squared. Alright, so then we just start plugging in all these numbers. So then this says 90% here. So determines the alpha over 2. That would mean this and this are 5 each. That means we're gonna have to do inverse norm of 0.95 squared times P hat Q hat, which is 0.29 times, this is 0.30, this is 0.71 for Q, all over E squared is provided to us. So 0.04 squared. Alrighty, yay. So second dister inverse norm 0.9, whoops, 5. Stupid idiot. Sorry, inverse norm 0.95. Okay, and then that is divided by 0.04, but then we wanted to square that part, I guess. I believe I got this. So if you need minimum sample sizes that you would need is actually larger than this number, because you need 348.17 people, so that means we have to round up in this case to 349. Does that make sense?
Yes.
Mostly just doing the formula. Alright, once they start providing you data here, it automatically is gonna be T every time. So they give you data, that should be good too, actually. So in this case, we're just gonna go and start just typing it in. This one, I believe, is the same one we did for our question earlier, though, when we were doing it in class. 15.8, 15.1, 15.5, 15.3, 15.0, 15.9, 15.7, 15.8. Now I just do what? T-interval, I guess. Because they want mean. Then we have data. It's in list 3, I think it was. And then this is 0.98. So we get whatever this is. Does that make sense?
Yes.
Use the given information to find the p-value. Also use 0.05 significance level state the conclusion about the null hypothesis. Reject the null hypothesis. Fail to reject the null hypothesis. Test statistic in a right tail test is this. So the alternative, he says right tail test, so it's the mean is greater than something. So that means if it's 0.05, all of the 0.05 is over here. 0.52, if Z is 0.52, like that's not far enough. So you're gonna fail to reject. I'll do it in a second, but there's no way this is reject. All right, so 0.52, 0 is right here, right? So we have to find out what the p-value is of this thing. So this would just be normal CDF. 0.52, 1E99. And we get this. And that's definitely not less than alpha. This is obviously greater than or equal to what alpha is. So fail to reject. Type 1, type 2 errors. Let's just review that again for a second. I don't even remember anyway, so. Type 1, type 2. What is this thing? So if the null is true or the alternative is true, you could either reject the null or fail to reject the null. If the null is true and you reject it, that's an error. That's type 1. So the type 1 error is the mistake of rejecting the whole when it's actually true. If the high is true and you fail to reject it, that's also an error. And that one is called type 2. So sometimes also the probability of a type 1 error is the probability of rejecting HO given HO is true. And the probability of a type 2 error is the probability of failing to reject HO. Given it's actually false. Formulate the indicated conclusion, non-technical terms, be sure to address the original claim. Carter Motor Company claims that New Suzanne Libra will average better than this. Okay, so then the alternative is that the mean will be greater than 32. Assuming the hypothesis test is conducted in the conclusions to reject. Okay, so if you reject, then there is significant evidence. To support the claim that the mean is greater than 32 miles per gallon. Question with that?
Nope.
The p-value of getting a test statistic at least as extreme is the one representing the sample, assuming that the null hypothesis is true. We always assume the null hypothesis is true. We always say the mean is equal to that number. You have to assume something to do it, right?
Mm-hmm.
Provide an appropriate response. Tim believes that the coin is coming up tails less than 50% of the time. He tests the claim that P is less than 100. All right, if 100 coin tosses, the coin comes up tails 57%. What? This is such a stupid question. Provide an appropriate response. Tim believes that a coin is coming up to tails less than 50% of the time. So Timmy thinks that the tails are going to come up less than 50% of the time. But then Timmy flips the coin 100 times and he gets more than 50%. And he's going to try and prove it's less than that? Yeah, good luck, Timmy. Fail to reject.
So Timmy's wrong.
Timmy's a schmuck. All right, no, this is important. The reason why I put this on here is because if you screw this type of thing up, you got a problem. You did not think about what you're trying to do. So, yeah, Timmy's a schmuck though. So like, I hate it when people start doing statistics when there's absolutely no reason to do it. Cause you're just like, why you're gonna waste your time doing all this crap when you already should know the answer just looking at it, right? So then they want us to do this. I mean, it makes the question easier for you. You don't have to calculate anything, I guess. But they want us to do this. So he doesn't mention what alpha is here, so that means we have to assume alpha is 0.05. If alpha is 0.05, then the rejection region, because the alternative is this, has to be on the left side. It's left-tailed. So that means this is 0.05, right? But p hat in this case is 57 out of 100. Or 57%, which is over here. There's no way that can be rejecting the thing. It's telling you it's wrong. If Tim believes it's coming up less than this sample is actually not validating that at all. So there's no point to even test it. So you must fail to reject. It's not sufficient evidence to support this alternative claim. Okay? Does it make sense why I'm saying that? The number's on the wrong side?
Yes.
Construct the indicated confidence interval for blah, blah, blah population means. Assume that the two samples are independent samples randomly. Okay, so they mentioned they're from normally distributed populations. That's good. So then, do not assume that the population standard deviations are equal. Independent samples come from two different populations, yield the following data. Sample size 478 for both. Okay, good. Find the 85%. Okay, so this is just pretty much just typing this in. So this is good. So this is stat tests. So we got to do one of these intervals. It's definitely a 2-sample one. They wrote S's here. They didn't give us sigmas, so we have to do T. So then this is stats. So you pretty much just type this crap in. Like this is not bad at all. Do you get what I'm saying with this one?
Mm-hmm.
This one you should, if you get this on your test, you should be happy also, in my opinion. Confidence level, 85%. We didn't really talk about pooling in this class, but specifically in this, it actually details how you decide whether it needs to be pooled or not. It says from two different populations. If we were saying that they're coming from the same population, we would pool the standard deviations together to try and figure out what the overall is. Or pool the samples together, I should say, to try and figure out what the overall standard deviation is. But in this case, we don't do that. So we do not use the pooled statistic in this case. So then we just do it the regular way, but you don't have to worry about that because we didn't talk about pooling. So this is mu1 minus mu2. Are we okay with that one? I guess I'll take that as a yes. Assume that you wish to test the claim that the paired sample data comes from a population with the mean difference is 0. Compute the value of the test as like round intermediate calculations. Okay. Does anybody have any question with the previous one? Or anything so far? Are we still here? I bored you too much.
Yes. You did.
Yes, you're here, or yes, you bored me too much.
You bored me too much.
Both.
A little of both.
Yes, I'm here.
No, I was just joking. Sorry. 28, 31. The reason why I'm doing it like this is so that you, first of all, don't get burnt out with all this stuff and you see how to do it. And I'm sure you're gonna start telling me that some of this gets a little redundant after we've done it so many times. So that helps.
Mhm.
And then, of course, you're going to be able to review the videos so you can go back to the parts that are, giving you a little bit more trouble. But if you do have a question, please feel free to contact me. Okay. I can go over it with you even during the Thanksgiving. All right. So in this case, assume they use the test game. They told you it's paired here, so that's kind of nice. But then once they start discussing mean difference between the two samples, you're gonna have to do the pairing. So we can chuck the paired thing here. All right, now I was pretty stupid. I should have honestly just did it out myself here. Because like this subtraction is kind of not worth typing all this in. But I was dumb and I was talking too much. So I should have just typed this crap in, honestly. You see it's the same. I've subtracted in a different order here. On this one, I'll do it the same. I did L2 minus L1. Let's do L1 minus L2. So you get the same numbers, okay? But it's pretty easy to do this usually for this type of thing. Now, effectively, it becomes one sample. Once it becomes one sample now, it's a means question. We have to do Z or T. In this case, we're going to do P because we definitely don't know what sigma is. So I just need to remember this is an L3 and I need to do a T test. We want to test against 0. It's an L3. We're doing not equal to 0 because all they said was test the claim that it comes from a population with the mean difference of 0. They didn't say they wanted to be greater or less than. And that is it. So we get T is approximately equal to negative 0.5233. We get the p-value 0.616. Yeah, I guess that's possible actually. 0.616. So this is 0.6169 because the X bar for the sample differences in this case, or the mean difference for the sample, was negative 0.625. So we have what? How many? 1, 2, 3, 4, 5, 6, 7, 8 data points. And the average difference was this. And they want you to say whether or not it's close to zero or not. So the thing is like this p-value is definitely bigger than alpha. We are definitely gonna fail to reject. And I feel like if you just thought of this, you would say the same thing. If someone samples 8 things and they want to see if something is different from 0 and the average is negative 0.625, I don't think that this is far enough away from 0 to start saying that I'm sure the answer is not 0. It's still too close. If I got like negative 625, I'd fine. Does that make sense? So
Yes.
there is not sufficient evidence to suggest the mean difference is not equal to 0. When testing the claim, damn, this thing's long. When testing the claim that P1 is equal to P2, a test statistics V is equal to this is obtained. Find the p-value. All right, so they want to test this claim, so then that means the alternative is P1 is not equal to P2. So they got 2.04, but we remember that when it's two-sided, to get the p-value, you gotta double the damn thing. So the p-value is equal to 2 times normal CDF, I guess. 2.041899. Now, again, remember, like, this is not the first one of these that we've had to do, but effectively what I start doing on the test is like, I don't actually always ask you to do the whole thing. And this is just asking you to do, you know, part of it here. So this is only step 3 when doing the hypothesis test. So we got this, I guess, 0.0414. Question with that?
Nope.
Assume that the following confidence interval for the difference in the mean length. Oh, by the way, your exam is shorter than this also. Assume that the following confidence interval for the difference in mean length of male and female babies at birth is constructed and easier. Was constructed using independent simple random samples, this thing. What does the confidence interval suggest about the difference in length between the male babies and female babies? It would suggest that there is no difference in length. Because if you tell me mu1 is minus mu2 is between some negative number and some positive number, and that means 0 is still included. In the interval. So if the null hypothesis was that mu1 is equal to mu2, which again is the same thing as mu1 is not equal to, or excuse me, mu1 minus mu2 is equal to 0, then you just subtract mu2. Then, like, we can't reject this. 0 is still here, right? We're somewhere between negative 0.2 and positive 1.7. 0 is still quite possible, so there's no difference. Or we can't say that the male babies or female babies are longer. What a strange question. Longer babies. Somebody wrote something in the chat. Oh, that's funny. All right. Any question?
Nope.
I guess we have to assume that they did the right confidence interval here, but whatever. When testing for a difference between the means of a treatment group and a placebo group, the computer display is obtained. Use a 0.04 significance level. Is there significant evidence to support the claim that the treatment group comes from a population that's different? Okay, so this is the mean of the treatment group equals the mean of the control group, I guess. And then this is, wait, which one? Treatment group is 1. Placebo is this one, which is the control. Does everybody know what placebo means?
Yes.
Alright, so then this is, let's just call them placebo because that's what it says in the question. So then, we wanna do this one is not equal to here. Alpha, they tell us is 0.04, so then that means. This is 0.02 and this is 0.02. Cause it needs to add up to 0.04. Okay. Alright, now I guess I better read the stupid table. What the hell did they give us here? Alright, so some statistics about some stuff. They gave us two-tailed probability, critical values, whatever. Okay. Well, they gave us the damn p-values here. You just have to effectively really just understand which one to read. So really, all you have to do is just realize that this says this is two-sided. And then you just read this one. So the p-value in this case is 0.0316, which if you wanted to calculate it, you don't have to though. The T here is 1.644853. So then you could do 2 times T CDF of 1.644853. 1E99, comma, degrees of freedom in this case is n minus is 49. So you could do this to start seeing what the answer is, but you don't have to because they already told you what the number is. So all you really need to do is just compare this to alpha. That's all you have to do. So 0.0316 is less than 0.04. Therefore, this is rare enough, so we should reject the hoe. Is there sufficient evidence to support the claim that the treatment group? Yes, there is. You should really regurgitate the sentence back and write it back and say it nicely and stuff like that. Yes, there is sufficient evidence that the treatment group comes from a population that's different from the mean of the control group or something like that. But if you just had answered yes to the question, I would have given you credit. Question? Oh,
Yeah.
excuse me. It says to explain also. So you would have to state that this is less than this, and that's it.
Hmm.
Was there a question? I'm sorry.
No. No question.
Another one, it looks like. 5 students took a math test before and up to tutoring. All right, so I guess we're gonna try and figure out if this tutor's worth anything. So I would be interested in doing after minus before in this case. So that'd be like 4. What is this? 9er. -2, he got worse that time. 3. 12. Just based off these numbers, I would say that looks like the tutoring is effective, but who knows? Let's see. All right, what do they want us to do? Use a 0.01 significance level, provide the confidence level necessary to perform the test using the confidence interval method. Okay, so it's not even asking us to actually do the whole test. I don't know. I didn't even need to do what I was just doing. All it wants us to do is explain what size confidence interval would be necessary to do this. So if this is what's the claim? Do they have a claim here?
Mm. Mm.
I don't see it here.
Mm.
So I would have to guess that they're trying to say that the mean difference is positive. Um, we kind of can't tell. Let's do two examples just in case on the test it's different. Alright, so in this first case here, which is the one-sided test. In the one-sided test, all the rejection region would have to be put over to here, right? So then this is gonna be 0.01. So if you wanted a confidence interval to end at the same place where the rejection region was gonna start, that means this would end up having to be 1% also. That means the inside part would be 98% confidence level. If they said that it was wanted to be this. If they had said that it's not equal to 0, then the problem is that you have to put the rejection region on both sides. So then if the alpha level was, what was it, 0.01? If alpha is 0.01, now this plus this is 0.01, so that means that's 0.005, and this is 0.005. So that means this inside part would be 99%. So what you could remember is that every time it's one-sided, the confidence level is 1 minus 2 times alpha. And every time it's two-sided, it's just 1 minus alpha. Or just draw the picture. I prefer just drawing the picture than memorizing something. But you could just remember, I don't want to make you memorize something, to be honest. Any question?
Nope.
I guess that's it. What did they say for the answer? I'm wondering. Is it not here? No, 47. Oh, I changed the question. That's why. Got it. Question
Nope.
about anything?
Nope.
Is it okay?
Mm.
Yep.
All right, you should be telling me that there wasn't that many things that we really had to do on there. Maybe the probability stuff is a little annoying that you don't remember a little bit. I do advise practicing some of those. Try and do this test without anybody helping you, and try and do it yourself. Obviously, you have all the answers and solutions. And it's pretty good practice for the final. Okay.
Mhm.
Do not forget to bring your calculator. This will be on November 30th, the final. Okay. So I will see you there. All right.
All right.
On the 28th, we will probably not necessarily have any scheduled thing to do in class. So that's about it, I guess. I will be there, of course, anyway, but we don't have anything really scheduled to do. All right, we're kind of done. Any question?
Nope.
No, thank you.
All right, if you do have any questions, please contact me and we can discuss it. All right.
For
Okey-dokey.
sure.
You do need to be present definitely for that final though. All right. So I will see you there. Alright?
Ciao.
See you
And if you do want to set up any meeting prior to that, we can do that as well. Okay?
for sure.
My pleasure. And also have a happy Thanksgiving.
You
Alright?
too.
You too.
Happy Thanksgiving.
Bye.
Bye-bye.
Bye.